So up to now we have discussed many first order linear differential equation like Ricardo differential equation, exact differential equation, linear differential equation, separable differential equation, and so on. Today we will discuss some application of the first order linear differential equation. Uh, the first one is the current in a series circuit, the compound interest, the population growth, the decay rate or radioactive decay, and the cooling of bodies. So the first one is the current in a series circuit, and in this topic there are some laws uh, just like Ohm law, the Faraday law, the Lenz law, and the Kirchhoff current law. फर्स्ट ऑफ ऑल जो हमारा टॉपिक होगा वो होगा LR सीरीज सर्किट का. Mean to say that if there is a circuit having an inductor and a resistor, then now what is the mathematical model of such type of a series circuit and how we can solve it. For example, here is a circuit in which an inductor is fixed and a resistor is fixed, and there is some impulse voltage, the source of a source of voltage rise. This is called the electromotive force. For example, आप consider करें कि आप किसी circuit में आपने बैटरी लगाई हुई है, which is the source of voltage rise. So according to Kirchhoff voltage law, the total voltage drop is equal to the total voltage rise in a closed loop. For example, here is the definition of Kirchhoff voltage law. The algebraic sum of all voltage drops around closed circuit is 0, or in any closed loop the sum of all voltages drops equal the impressed voltage rise. Similarly, Ohm law says that the voltage drop across a resistor is given by IR. For example, if there is a resistor which has a resistance R ohm and the current flowing through this resistor is I, then the total voltage drop across this resistor will be Ri. And similarly, according to Faraday law and Lenz law, the voltage drop across an inductor is actually proportional to the instantaneous rate of change of the current. Means to say that the voltage across the inductor voltage drop across the inductor is given by L di by dt, where this L is the inductance of the inductor and di by dt shows the rate of instantaneous rate of change in the current with respect to time. Now, if we are discussing an LR series circuit, it means that the circuit contains an inductor and a resistor. So what is the voltage drop across the resistor is Ri, and what is the voltage drop across the inductor is L di by dt. So the total voltage drop in this circuit will be the sum of these two, Ri plus L di by dt. And let's suppose if there is a source of voltage rise EMF, then it becomes EL plus ER is equal to E of t, where this EL is the voltage drop across the inductor plus voltage drop across the resistor. So on the left hand side here is the total voltage drop across in this circuit, and on the right hand side this is actually the voltage rise. So जो mathematical model है, EL is given by L di by dt and ER is you know that this is IR is equal to E of t. So this is the mathematical model for a circuit having a resistor and an inductor. ये आपने याद रखना है. L is the inductance of the inductor, R is the resistance of the resistor, E of t is the electromotive force, I is the current, and this term shows the rate of instantaneous rate of change in the current. So background जो है आपको ये जो मॉडल है which is a linear first order differential equation, इसमें जो है आपका ये कंसेप्ट क्लियर होना चाहिए कि ये हमने एक्चुअली किरचॉफ वोल्टेज लॉ को यूटिलाइज किया है. लेफ्ट हैंड साइड पे टोटल वोल्टेज ड्रॉप है और राइट साइड पे वोल्टेज राइज है. So this is actually the mathematical model for such a circuit having an inductor and a resistor. So for example, if we discuss problem number 1, which says that a 12-volt battery is connected to a series circuit in which the inductance is 1 by 2 Henry and the resistance is 10 ohm. Determine the current I if the initial current is 0. सो 12 वोल्ट की बैटरी फिक्स है किसी सर्किट में और उसमें एक इंडक्टर है जिसका इंडक्टेंस 1/2 हेनरी है. हेनरी इज द एसआई यूनिट फॉर द इंडक्टेंस ऑफ इंडक्टर एंड रेजिस्टेंस इज 10 ओम. रजिस्टर लगा हुआ है, उसका रेजिस्टेंस 10 ओम है. डिटरमिन द करंट आई. इस सर्किट में करंट फाइंड करना है. इफ द इनिशियल करंट इज 0 मीन टू से दैट इनिशियली द करंट इज 0. This is actually the initial condition for this problem. So we know that the mathematical model is given by L di by dt plus Ri is equal to E of t, putting the value of this L, R and E of t. E of t is given by 12 volt, so 12 volt यहाँ पे put करें. R की जगह 10, R is given and similarly L is given is 1 by 2. 1 by 2 di by dt plus 10I is equal to 12. Subject to the initial condition. अब ये initial condition I of 0 is equal to 0, ये यहाँ से if the initial current is 0 mean to say that if t is equal to 0 the current is 0. Now multiplying this is a linear differential equation but not in the standard form. इसको standard form में लाने के लिए अगर हम 2 से multiply करें तो di by dt का coefficient 1 बन जाएगा. So di by dt plus 20I is equal to 24. linear differential equation है और अभी हमने recently पढ़ा है कि इसको हम किस तरह integrating factor find करते हैं. e to the power the coefficient of this I which is 20, e to the power 20 t इंटीग्रेटिंग फैक्टर है और इसको हम यहाँ पे थ्रू आउट मल्टीप्लाई कर देते हैं और इसका जो लेफ्ट हैंड साइड है दिस कम्स आउट टू बी द डेरिवेटिव ऑफ इंटीग्रेटिंग फैक्टर एंड डिपेंडेंट वेरिएबल विच इज आई इन दिस केस और राइट साइड पे ये आ रहा है. अब यहाँ पे जस्ट इंटीग्रेट करें इसको. इंटीग्रेशन के बाद हमें मिल रहा है इंटीग्रेशन डेरिवेटिव विल कैंसिल ईच अदर, वी विल गेट आई ई टू द पावर 20 t और यहाँ पे 24 और इसका इंटीग्रेशन e टू द पावर 20 t डिवाइड बाई 20. So 24 divided by 20 is 6 over 5 e to the power 20 t plus some constant of integration. Constant of integration को find करने के लिए हम initial condition को use करेंगे. I of 0 is equal to 0. So यहाँ पे t की जगह 0 put करें तो I of 0 is equal to 0 है. 6 over 5 plus a और e to the power 0 1 बनेगा और a is equal to minus 6 over 5. Put this value of a in this equation, we get the solution or this is actually the current. I of t is equal to 6 over 5 minus 6 over 5 e to the power minus 20 t. नेक्स्ट वीडियो में हम इसको डिस्कस करते हैं. थैंक यू.